Okay, in 9.1, we're going to look at radical expressions and functions. First, I want to talk about what a basic radical expression looks like. And we have a radical sign. And I'm going to just label a few things here. This says the nth root of a. So you've seen things like the square root of a or the square root of 4. The n stands for your index. So if it's a square root, so I'll just, for example, write the square root of 4. In this case, the index is considered to be 2 for square root, but we don't write that 2. So if you don't see an index written inside of that little check mark there, then it's a 2, and it stands for the square root. Any other root will be written. And then this sign right here is our radical sign. And the a, or the term under the radical sign, is called a radicand. Okay, so now that we've labeled things, let's talk about what a radical is. So we're going to start with square root. And the square root, let me move up a little, of a number is a value that when multiplied by itself gives the number. So for example, the square root of 9 equals 3 because 3 times 3 equals 9. So the square root of 9 is saying what number multiplied by itself gives you 9, and that is 3. So let's simplify some of these. The square root of 36, this is saying what number multiplied by itself gives you 36, and this is 6. So square root of 36 equals 6. Square root of negative 25 is saying what number multiplied by itself gives you a negative 25. And if you try, for example, 5 times 5, that's not going to work. And if you try negative 5 times negative 5, that's not going to work. Both of those equal a positive 25. And so the square root of negative 25 is a non-real answer. This is an imaginary solution, and we actually don't cover those in this class. So we're just going to write it's a non-real answer. The next one, square root of 1/16, says what number multiplied by itself gives you 1 over 16, and that would be 1 over 4, or 1/4. And for the last example, negative 3 times the square root of 64, this is multiplication when you have a number in front of the radical sign. This would simplify to be negative 3 times the square root of 64 is 8, because 8 times 8 is 64. And then you would just go ahead and multiply those two and get negative 24. So let's simplify radicals. So to simplify variables, I'm going to show you this a little bit differently than my math lab might show you. So what I say is divide the index into the exponent of your variable, of each variable that you have. This tells you how many of the variables you can take out of the radical sign. So let me show you how this works. So I'm just going to divide. We do have numbers here, so I'm going to have to deal with the numbers as well. But let's just start here. We have the square root of 121 b to the 6. So let's start with the square root of 121, and that is 11, because 11 times 11 is 121. And then we're going to go ahead and do that division. So remember, if the index isn't written, it's considered to be a 2. And we're just going to do basic division. 2 goes into 6 3 times, so I can take 3 b's out of the radical sign. And right now, all of our indexes are going to divide evenly into our exponents. Later on, I'll show you what to do when they don't. So for b, we're going to take the square root of 81, and that is 9. Again, our index is 2, and 2 goes into 8 4 times, so we can take 4 a's out of the radical sign. For c, you have a negative in front of the radical sign, so you need to keep that negative out in front, and then we're going to take the square root of 16, which is 4. Again, our index is 2, so I'm going to go ahead and divide. 2 goes into 10 5 times, and 2 goes into 2 1 time. So it's negative 4 a to the 5th b. For the last one, we're going to have 2 outside. We're going to take the square root of 9, which is 3, and we're going to divide. 2 goes into 8 4 times, 2 goes into 4 2 times, and 2 goes into 12 6 times. And then the only other thing you want to do is simplify. 2 times 3 is 6. So we get 6x to the 4th y squared z to the 6th. I said 6 and then I didn't write that there, so let's fix that. Okay, so cube root is very similar, except instead of looking for what number multiplied by itself 2 times gives you the number under the radical sign. For cube root, it would be 3 times. So the cubed root of a number is a value that when multiplied by itself, three times gives the number. So for example, the cubed root, so I'm going to have an index of 3 for cubed root. The cubed root of 27 equals 3 because 3 multiplied by itself 3 times gives you 27. So let's go ahead and do a couple of examples. Let's do the cubed root of 8b cubed. So the cubed root of 8 says what number multiplied by itself 3 times gives you 8, and that would be 2. And then I'm going to divide my index into my exponent. 3 goes into 3 one time. For b, it's hard to see as this says the cubed root of negative 27, a cubed. So cubed root of negative 27, what number multiplied by itself 3 times gives you a negative 27. And for an odd index like this, you can have a negative number because a negative 3 multiplied by itself 3 times gives you a negative 27. And then divide 3 into 3 and you get 1a outside of the radical sign. For C, I need what number multiplied 3 times gives you negative 64, and that would be negative 4. And what number multiplied by itself 3 times gives you 125, and that is a 5. So this simplifies to be negative 4/5. For this last example, I have a 4 outside, cubed root of 216. I want to know what number multiplied by itself 3 times gives you 216. You can do this on your calculator. Cubed root is under math. And you would just type in the cubed root of 216. But you can also have that chart that shows you the perfect cubes, and the cubed root of 216 is 6, because 6 multiplied 3 times is 216. And then 3 goes into 9 3 times. And then just simplify. 4 times 6 is 24. Okay, nth root, I just want to write down what we kind of talked about with even and odd indexes. If you have an even index, if you have a negative number under the radical sign, you have a non-real solution. So you can't have a real solution if you have a negative under a square root, a fourth root, etc. But for an odd index, you saw you can have a negative number under a radical sign because a negative number multiplied together an odd number of times will still be negative. Okay, so we're going to go ahead and do the fourth root of 16. This is asking what number multiplied by itself 4 times will give you 16, and that's 2. 2 multiplied 4 times is 16. And then the fifth root of negative 243, what number multiplied 5 times gives you negative 243? And that is a negative 3. And then 5 goes into 10 2 times. Okay, here's a radical function. G of x equals 3 plus cubed root of x. Find g of 2. And then it says round to the nearest hundredth, which is 2 decimal places. So g of 2, I'm going to plug in 2 for x. And then I have to use my calculator because we can't find the cubed root of 2. That's not a whole number, that's a decimal. So plug this into your calculator, be 3 plus, hit the math button, find the cubed root, and type in 2. And you should get, if I round to 2 decimal places, 4.26. Okay, let's look at this radical equation. It says many birds drop clams or other shellfish in order to break the shell. The time t in seconds it takes for an object to fall is given by this equation. Okay. A gull drops a clam from a height of 50 feet. A second gull drops a clam from a height of 32 feet. Find the difference in the time it takes for the clams to reach the ground, round to the nearest hundredth. So 2 decimal places, and find the difference means I want to find the difference or subtract these two values. So I'm going to do the 50 and the 32. So I want to know t, that's what I'm trying to find, and I know here the distance is 50, so I just plug it in for d. And here I know the distance is 32. Then you just plug this into your calculator. If your calculator puts a parentheses after your radical sign, make sure you end it so it doesn't think the 4 is part of the radical inside the radical sign. But go ahead and plug this in, and for this first one you should get approximately 1.77 seconds. That's to round it to the 100th place. And for this one you should get 1.41 seconds. So then it asks us to find the difference between these two. So how much faster is one over the other? So we subtract, and we get 0.36 seconds. Okay, we're now going to graph the radical function f of x equals the square root of x. So I just want to know what the basic radical function looks like. So you can graph this on your calculator. And whoops, let me clear that actually. Hold on one second. I'll put the back up in a minute. And so I don't have my 83 simulator on here yet, so I'm going to use this graphing calculator just to show you what it looks like. On yours, you have a Y1 button or Y equals button. You would click that. That's at the top of your calculator. And then you would type in the square root, and you have an X button. And then you have a graph button. Mine happens to be over here on the right. Yours is at the top of your calculator. You just hit graph. I wonder if it wants me to end the parentheses. There it is. Okay. And so this is what the radical function looks like, the square root of x. Okay. Notice it goes through, so I'm just going to label a couple of things. Starts at the point 0, 0, and there's no negative values, because remember, for a square root, you can't have a negative under the radical sign. All of these would be non-real solutions. So it starts at 0 and goes on to infinity. And so let's write the domain and range for this graph. The domain is all the x values, so starting at negative infinity on the x-axis, I'm going to go across to infinity. So if I go across, my first x values start at 0 and then go on continuously. So my domain is x is greater than or equal to 0. And you can write it like that or in interval notation. Either way is fine. And then my range, again, starting at negative infinity and going to infinity, my y values start at 0 and then go on continuously. So this would be y is greater than or equal to 0. Okay, now let's graph f of x equals the square root of x minus 4 minus 5. So I'm going to go back to the calculator, and I'm going to plug in square root of x minus 4. And this is important. This needs to be in parentheses to show this is what's in the under the radical sign. And then you might need to end your parentheses, or in some of the other calculators you have to use the arrow key to get out of that parentheses. Just depends on your calculator. And then you put the minus 5. This shows the minus 5 is not inside the radical sign. And then when you graph that, it should look like this. Notice the minus 4 tells you your graph has moved 4 units. It's the opposite of the sign, so 4 units to the left. And the minus 5 that's outside of the radical sign shows your graph moved 5 units down, so it's the same sign. Okay, so this is basically, let me write this here. So this point right here is the point 4, negative 5. Okay, so the domain for this will help me with the domain and range. The domain, I start at negative infinity and go across, and my first x value starts at 4, and then goes on continuously, so x is greater than or equal to 4. For my range, I start at negative infinity and go up. My first y value starts at negative 5 and then increases, so this is y is greater than or equal to negative 5.